Okay, continuing with section 6.2. The next thing that I'm going to do, I've already done, let me see, 1 through 3, 4, 6, and 15. So let me start off with number 5. Okay, so in number 5 in the homework outline, I'm just going to do it on regular paper, and then you can choose the answer from the outline. But they start you off in problem number 5, and they give you theta is equal to pi over 3. So what they're telling you, you have to look for any clue they give you that tells you where to rotate so that you know what kind of triangle you're in. So you may want to convert this to degrees. 180 is the same thing as pi divided by 3. They're telling you to rotate to 60 because this angle that they're giving you right here is your central angle. It is the angle connected to the origin right at the center of the circle. So in this particular problem, they want you to give the point, the coordinates of a point. In other words, the x and the y on the unit circle if you rotated to 60 degrees. So here's, let's make that look sort of like it's 60 degrees at the center. And right from the edge of your rotating arm, you can drop down to the x-axis. That would make this 30. You can put that inside of a circle if you want. Okay, that'll be y, this will be x, this will be your radius of 1. You're in a unit circle for these problems. Okay, always across from the 30, short leg. Always across from the 60, long leg. Any leg that runs up and down like a y-axis, that is your y coordinate, also known as your sine value. Any leg that runs horizontally is also known as your x value, or in other words, your cosine. That's because the sine formula is defined as y over 1, and the cosine value is defined as x over 1. This is just the x-axis. That's why you see an x there. So anyway, there are values that go specifically with a 30, 60, 90, which is what this section's about. Your short leg is always 1/2 of the hypotenuse, and your long leg is always square root of 3 times this short leg, or in other words, square root of 3 over 2. So then when they ask you, what is the point associated with a 60-degree central angle, you give them the x coordinate, which is your horizontal leg, and your y coordinate, which is your vertical leg. Okay, and on your homework outline, that's choice number 1. If you have printed the outline, you see the choices, and you should be taking the notes with the homework outline and the theorems right in front of you. Problem number 6. I think I did that one already in the last video. So we'll go to number 7. In number 7, you're being asked for the sign at what's called a quadrantal location. See, notice that in most of the pictures in all the pictures I've done thus far in this section, when I did rotate, in other words, my hypotenuse is always my rotating arm, I was always in between two axes. So I was able to draw a triangle. Here, you're going to land right on a specific axis, and therefore, this is called a quadrantal angle. I had mentioned this when I was giving the notes for 6.1. Means you're going to rotate to an axis, some kind of axis, either a y or an x-axis, and you will not be able to draw a triangle. So don't try to force one out, because I always see, I see students that don't understand where they're at and why they can't draw a triangle. But you can't do that when you're at a quadrantal angle. But it doesn't matter, because what if we really needed to answer any of these problems? An x, a y, and an r. The r is given. It's just a 1. But the x and the y, you can get it whether you're drawing a triangle or whether you're not drawing a triangle. Like for instance, if we rotate to 4 pi, because they're telling you where to rotate here, you would go 2 pi, 4 pi, 3 pi, no, sorry, 1 pi, 2 pi, and then 3 pi, and then another 4 pi. You'd land right back where you were at 2 pi. You just rotated an extra revolution. So because you're right on the x-axis, you cannot draw a triangle, but you can still name the coordinates here, the x and the y coordinate. You know that you're inside a unit circle where the distance from the center to the edge is 1, but that also helps you name the x and the y coordinate. You're out a horizontal distance of 1, and this point is located 0 units up in the air. So this is your x, this is your y, this is your r. So you can answer any question they want. And specifically, the question here is, what is the sine value at 4 pi? Sine is defined as your y value. Your y value is 0. So that's your answer right there. Just going into a lot of explanation about what it means to draw a quadrantal angle. Okay, next problem is going to be, that was number 7. So now I'm going to do number 8. So in problem number 8, you are asked to do, get a better pencil here, sine of 60 times cosine of 60. So here they go, giving you a hint about where to rotate to. You're going to rotate to 60. They gave it to you in degrees. So here's your rotator. Let's make that look like it's about 60 degrees up in the air. Feel free to wrap the circle around it. Not going to affect our values here. And put the 30 up here so you're very clear where the short leg and the long leg is. So across from the 30 is the short leg. Therefore, it's 1/2 because the short leg is always half of the hypotenuse. The hypotenuse, when you do draw the circle, is right where the radius stops. The hypotenuse and the radius are the same thing. Okay, so don't forget, this is x, this is y, if you want to wrap the circle, but you really could have put all these values on the right triangle without the circle. Just remember the hypotenuse is 1 because it really serves the purpose of the radius. Then your long leg is always across from the 60, and it is always square root of 3/2. So now when you come back to the problem, you have everything you need, because the sine, remember you're in a unit circle, so things have specific definitions, like sine is defined as just the y value. Whenever you have two functions next to each other, that's indicating multiplication. Cosine is defined as x. And you can get these values right off the triangle that you created. So the y value is always this leg that runs up and down like a y-axis. The x value is the leg that runs horizontally like an x value. That x that you see there is just how, we're labeling the x-axis. This represents the x value, this leg. This value, square root of 3/2, represents the y value. Okay, so the x is the 1/2, and then when you multiply these as requested, you get top times top, square root of 3/4. That's your answer for that problem. Okay, moving on. Let's see what I have not done on the next page yet. The next one is problem number 9. Let's see if I have room to do that one here. So in problem number 9, they're saying do 2 times the sine of pi over 6, indicating that you need to draw a picture where you've rotated to pi over 6. And then you're going to subtract 6 times the tan of pi over 4. Again, you might want to convert these into degrees just to get yourself more familiar. If you put a 180 in here, you're allowed to replace pi with 180 because they're equivalent. So substituting a 180 right in there, divided by 6, they're really telling you build a triangle with 30 degrees at the center. Pi divided by 4, that would be 180 divided by 4, and that would be 45 degrees. So they're really saying build a triangle with 45 degrees at the center. So I'll provide both of those pictures for you again. After a while, you're just going to memorize these values. But when there's 30 at the center, the short leg is the y value, because the 60 would be up here, making this the long leg. And of course, the hypotenuse is 1. When you're in a 45, a lot of students stop drawing this picture very quickly into the course because they memorize that both legs are the same, and this is what they both are. Square root of 2 over 2, radius is 1. Then come back to the problem. Sine value is really your y value. Make sure you're looking at the 30-degree picture with the 30 degrees at the center. Your y value is the leg that runs up and down vertically. Okay, so that would be 1/2. Then it's minus 6. And then your tan value is defined as y over x. These were from the very first page where all the definitions were. You're just doing them for specific triangles now. So if you're doing the tan that has 45 degrees, which is why it had two legs that were equal, the tan value would be y, that's this square root of 2 over 2, over x, which is also square root of 2 over 2. So I'll write this out, but I don't think we really need to do that anymore, hopefully. When you're at 45 degrees, this definition of y over x would give you square root of 2 over 2 divided by square root of 2 over 2 over 2, square root of 2 over 2, which has to be 1. So that's what goes right there. So now to finish this problem, 2 times 1/2 is 1, minus 6 times 1 is 6. Final answer, I'll put it over here because I'm going to run into that definition, would be -5. Okay, moving on to, let's see, we'll go over to the next page of the homework outline. I'm just going to continue doing these on paper so I have enough room. You're asked to find the sine, cosine, tangent, cosecant, secant, and cotangent at 5 pi over 6. This is all they start you off with. So like I said, look for any indication in the problem of an angle. Whether it's in pi form or degree form, doesn't matter, because you can very easily convert a pi type number, a radian type number, to degrees. Just plop a 180 in there for pi. You're allowed to substitute in one value for another if they're equal. So if you put that in your calculator, you're going to get 150. That means rotate to 150. You're always rotating to whatever they're asking. You know, you might say, well, what happened to the 30s, the 60s, and the 45s? This is a cousin to one of those. It's just that you're going to be in a different quadrant because you're rotating pretty far, but you're still going to be in one of those special right triangles. So rotating to 150, please try to recognize the landmarks going around a circle. Every time you pass through a quadrant, it's 90, another 90. Another 90. If you don't know the landmarks, you don't know what quadrant to stop in when you're rotating to 150. So rotating all the way to 150, which would have to be you stopping somewhere before you get to 150. How much are you stopping? Well, if from here to here is 150, then this must be the additional 30. 150 plus an additional 30 gives you the 180. So right here at the center, so you do know your central angle is 30. Come straight down to the nearest x-axis. That would make this 60. It would make this the short leg, which is 1/2, also known as the y value because it represents this leg that runs up and down. I'll finish this problem next video.